Number 42, a mole is a unit of measurement used in chemistry. The masses of 1 mole of 3 elements are in the table. A mole is a number of atoms. I think it's 6.022 times 10 to the some power. I think it's like 10 to the 18th power. It's a huge number. So if you took a huge number of all these tiny atoms, this is how much they'd weigh. 6 bajillion atoms of hydrogen weighs this much. 6 bajillion atoms of carbon weighs this much, and so forth. So we're going to use this table. Part A, a 100-gram sample of ascorbic acid contains 4.58 grams of hydrogen. To the nearest tenth, find the number of moles of hydrogen. At 100 gram, that can just kind of throw us off. What you want to look at is hydrogen. For hydrogen, in 1 mole, I have 1.008 grams. That's how much it weighs. A mole of hydrogen weighs 1.008 grams. Well, we have 4.58 grams of hydrogen. We want to make sure we put things in the right spot. I labeled grams here, so I'd remember to put grams on bottom. If I have 4.58 grams of hydrogen, how many moles do I have? Well, 4.58 times 1 divided by 1.008. We're supposed to go to the nearest tenth. We get about 4.5 moles for part A. Part B, a 100-gram sample of ascorbic acid contains 54.5 grams of oxygen. Find the number of moles of oxygen. So for oxygen, I have 1 mole weighs 15.999 grams. In my sample, I have 54.5 grams of oxygen. How many moles is that? Well, just cross multiply and divide. 54.5 times 1 divided by 15.999. And to the nearest tenth, we're looking at about 3.4 moles. The ratio of moles of hydrogen to moles of carbon in ascorbic acid is 4 to 3. So that means we have 4 moles of carbon. No, I'm sorry. Let's see. Moles of carbon, hydrogen to carbon. So let's see here. Okay. 4 moles of hydrogen to 3 moles of carbon. How does this ratio compare with the ratio of moles of hydrogen to moles of oxygen in ascorbic acid? Well, if we look at the ratio in our sample, remember we had ascorbic acid. It had 4.5 moles of hydrogen. It had 3.4 moles of oxygen. So what is that ratio? If I took 4.5, the ratio of, remember we're looking at hydrogen to oxygen. We've got 4.5 moles of hydrogen to 3.4 moles of oxygen. What happens when I take 4.5 divided by 3.4? I get about 1.32. And if you look at the ratio of hydrogen to carbon, 4 to 3, that's about 1.33. So what do we notice about the ratio of hydrogen to carbon? It's almost the exact same as the ratio of hydrogen to oxygen.